Hello, hope you guys are doing well. So today we are going to solve the problem, check if array is sorted and rotated. Like yesterday we solved the problem, like we have to search in rotated sorted array. Today we are solving the problem. We are supposed to check if our array is sorted and rotated. First we'll read the problem statement. Given an array nums, return true if the array was originally sorted in non-decreasing order, then rotated some number of positions including 0, otherwise return false. Right? If it is if it is sorted and if it is rotated any number of times from 0 till the number of elements in my array, that is my length, then we have to return true, otherwise we are going to return false. There may be duplicates in the original array, right? There may be duplicates in the original array. Note, an array A rotated by x positions result in an array B of the same length, such as bi equal to a I x plus x mod a dot length for every valid index, right? So let's so this is my problem statement. We are supposed to do what? Check if array is rotated and sorted, right? So we are given with an array and it may contain some duplicate elements also, right? So ARR equal to 1 1 2 3 4 10, right? If I am rotating it one time, what will be my resulting array? Oh, let's say it rotated two times, so my resulting array will look something like this: 2 3 4 10 1 1. So in this case I am going to return what? True, right? Let's copy each of our test cases. So this is my array, right? So is it rotated sorted array? 3 4 5 1 2, right? Yes, it is. Then 2 1 3 4, right? It's 2 and then 1 3 4, right? So it is not, because what if we sort it in ascending order, it will look like something like this: 1 3 4 2. So it is not rotated sorted array. If we start from any moment of time, then it has to be like this: 1 3 4 2 3 4 2 1. So it is not sorted array, right? Then another case will be 1 2 3. So it is rotated sorted array. Like it's sorted and rotated how many times? 0. So it will return true, right? No matter in how many position I rotate this, I will not get my array as sorted, right? Let's plot the graph for each of them. For this case, let's say if I am plotting 1 2 3 4 5, right? And this 1 2 3 4 5. So very first point it will be 3, then 4, then 5. Another case will be 1 and then 2, right? So this is how my plot graph will look like, right? So it's first increasing and then again increasing, right? And there is clear partition between both of them. So if I compare, like, how many inversions are there, I can bear at most one inversion, right? Inversion is what? Let's first understand the definition of inversion. If we are reverse ordering, let's say my array is in increasing order, right? If somehow I encounter an element that is decreasing, right? So we did one inversion, right? So we can bear how many inversions? Only one inversion, right? So if I compare this number with this, it's increasing, so it won't impact our inversion. Again it's increasing, right? And then this number is, if this number is compared to this number, it's decreasing, so our inversion will become +1. If I compare this element with this element, it's again increasing, so no impact will happen on my inversion. But if I compare this element with this element, right, it's increasing, it's again increasing, so it won't impact. Somehow this number was lesser than this, then our inversion, I have to do it first. I'll compare these two elements, then these two elements, then these two elements, then these two elements, and then the last and the first one, right? I have to do for this also, right? So clearly I have one inversion. So if somehow I encounter inversion 1, then my resulting array will is rotated sorted array, and I'll simply return true. Let's consider the case of 2 3 4, right? Let's consider the case of 2 3 4 and 1. 2 will be here, 3 will be here, 4 will be here, and no, first it is 2 and 1 3 4, right? 2 1 will be here, 3 will be here, and 4 will be here, right? So eraser, let's erase this. So this is my this is not my rotated sorted array. If I compare 2 and 1, it will, because we are decreasing, so it will result in what? 1 count inversion. 1 3 increasing, so no count inversion. 3 4 again it's increasing, but 4 2, after 4 we are decreasing, so how many inversions do we have out here? 2. So whenever I encounter the inversion count greater than 2, I'll return what? False, right? So I think it's clear. We are though, so I'll write the algorithm. First, my definition is iterate through the whole array, and even we have to take it cyclic, because it's cyclic, right? Whenever inversion is if we are somehow decreasing in the right direction. If my number is decreasing in right direction, from left to right, just left and left plus 1, so I'll encounter an inversion. So, and I can at most pair one inversion, right? That's my rotated sorted array. I can bear one inversion, right? Because if you take any of the array 1 2 3 sorted array, right? How many inversions are there in sorted array, and it's rotated 0 time? It's plus 1 only. And even if you rotate it, our count inversion will remain same, right? 1 1 2 3 4 4. After 4, 1 is decreasing, so I can bear at most one inversion, count inversion, right? So my task is simply to find out the inversion, right? So let's find out how we are going to find inversion, right? Initially keep the count inversion count 0, count inversion equal to 0, right? This is my algorithm, and I am given with nums array, right? If nums of 0 is less than nums dot length minus 1, right? So how many count inversion will I have? Count inversion plus count inversion plus, because my first number is less than the last number, and that's my sorted array, so I'll increase my count inversion. Now iterate over your array. For int I equal to 1, I less than nums dot length I plus, right? If nums I is less than nums I minus 1, increase your count inversion. So I'm going to increase my count inversion by what? By 1, right? Once it is done, close your if else loop and for loop, and finally check the condition. If I can bear how many inversions? At most 1. Count inversion less than or equal to 1, right? Why less than or equal to 1? For an array of length 1, my count inversion, how many count inversion do I have? 0, right? For this case also it will pass. And finally, what is my time complexity? It's big of n. What is my space complexity? It is big of 1, right? Let's write the solution for this. So initially count inversion will be what? Inversion will be what? 0, right? If nums of 0 is less than nums of, take the length of my array, int length equal to nums dot length minus 1. If num0 is less than nums of like len minus 1, that is my, if 0th index and the last index, if they are less than, that means the array is already sorted. So increase your count inversion plus plus, right? For int I equal to 1, I less than len let's remove this thing, I less than len I plus plus, right? If nums I is somehow decreasing, then I am encountering an inversion. So increase your count inversion count, right? If count inversion somehow reach its over optimum, like its early exit, if count inversion is greater than or equal to 2, then do what? Return false, right? Because I don't want my count inversion to reach like beyond 1. If at some stage it reaches 2, immediately return false, right? No need of checking in like later. And finally somehow I come out of the loop, check if my count like it will be like 1 only, right? If it would have been 2, it would immediately return false, so return true, right? No need of checking the condition. So let's submit the solution, right? So let's see my whole solution. So my time complexity is big of n, right? Space complexity will be what? Big of 1, right? That's it. That's all from my side. Thank you very much, and if you guys have any doubt, feel free to ask, like please feel free to comment. I'll try to resolve them. That's all from my side. Thank you. Bye bye.